So actually we do know very little about the effects of micro and nanoplastics in health and disease. So personally I think that we don't have enough understanding to evaluate the risks, if any. So there is some evidence already that these particles might have effects on health, but we actually do not know that.
There is such an overabundance of literature about how, where you find plastics in the environment, and yet there's such little information about where it is in human tissues.
We're trying to figure out how and if microplastics can pass the placental barrier and what kind of effects they can have on the placenta and also on early life development.
So AURORA is a large research collaboration between researchers, communication specialists and project managers from 11 different organizations. AURORA actually stands for Actionable European Roadmap for Early Life Health Risk Assessment of Micro and Nanoplastics.
The project is split into different work packages, and in these work packages, experts in each field work together across 9 different countries.
So I'm mostly focusing on work package 1, which is really setting up workflows and also detection techniques for these micro nanoplastics. And also with the experience I have in these microscopic and spectroscopic techniques, I was asked to join there.
And there we are focusing on the in-depth characterization of micro nanoplastics in the samples that are studied within AURORA. So we're looking at morphology of individual particles. So there are two aspects, particle counting, and that is really what our group is doing here in Utrecht in the ICC group. Looking at high-resolution microscopy to study morphology of particles, individual particles, the chemistry of particles, identifying particles, staining them, but also now recently making some micro nanoplastics. And we really focus on the smallest size fraction.
We have placenta tissue that was donated by women who gave birth. And that tissue, we try to actually digest the biological matter without destroying any plastic particles that could be in there. But since it's rather difficult to find plastic particles in human cells, we for now actually add plastic particles that have a very defined size and shape and are fluorescent, so we can find them back very easily.
I'm part of work package 2. This is the high throughput scalable assessment package to figure out ways to characterize microplastics in human tissues using mass spectrometry approaches. We're pairing some really interesting sample preparation approaches with these high-resolution mass spectrometry approaches to very thoroughly characterize plastic load in a given human tissue.
Second work package is mainly focused on analytical determination of polymers and biomarkers of plastic contamination. So the group on Mount Sinai is focused on non-target analytical screening, and Recetox will continue with biomarkers analysis in human samples.
I'm working in work package 3, which is using all sorts of toxicological assays to look at the uptake, transport and toxicity of micro nanoplastics within the placenta tissue, but using in vitro models. The placenta is very species-specific organ as well, so it's very, very unique to humans. So, and of course, ethically we can't use placentas during pregnancy to do any research either. So we really heavily rely on in vitro modeling.
I'm currently working on in vitro models to build a placenta in vitro to see whether the microplastics can enter the placental cells and can transport the placental barrier.
And our goal is to really discover and explore what happens when placenta cells come in contact with these micro and nanoplastics. We're not sure what effects they might cause, and so really this is basic fundamental research into biological processes that may change after exposure to microplastics.
I'm involved in the epidemiology work package where we are really looking into the effects actually of those micro and nanoplastics on human health.
I'm in the work package on epidemiology, so the birth cohort is involved there link the exposure, or the people working on the exposure methodology, to apply it in the samples that we have biobanked, and then to study what are the health outcomes or microplastics might be involved in.
And then my work in work package 5 is setting up a proof of concept study. I'm working with a group of Dutch women. There's going to be about 50 women in our study, and we're going to really describe and characterize the household microplastic environments. Do we see relationships between the home environment and then the amount of micro and nanoplastics we can detect in the blood and possibly in the urine as well?
So we're doing a gap analysis. What are the regulatory frameworks for risk assessment for micro nanoplastics right now? Several other projects are doing that. We have our own special focus, focusing on early life, maternal and developmental toxicity.
So we at the Food Packaging Forum are part of Work Package 6, where we're responsible for dissemination and communication within the project. And this includes communicating the research findings and making these results really actionable by ensuring we can create a dialogue and really inform all the different stakeholders who are interested in this research on micro nanoplastics and early life health.
The Work Package 7 all covers all the non-scientific part of the project. So a big part is really the interaction with the European Commission, so the funder of the project, but also monitoring if all the deliverables are met and if all the requirements that the EU has on a project are met. A lot of reporting, a lot of administrative stuff, but also a lot of legal stuff, ensuring that all the agreements are in place for shipment of samples and things like that.
I think it's a really important topic when there is really a public concern. There is a societal question, and I think we have a duty as scientists to try to come up with the evidence that would support potentially future policies. At this moment, we don't know how to regulate micro nanoplastics. We don't know which regulations that we have in the European Union is actually suitable for the problem of micro nanoplastics.
Of course, the effects that we may find are maybe not so nice, but it's really important that we figure it out before we are exposed more to these microplastics, and we need to prevent harmful effects. And the only way to do that is do more research.
It's really great to see the eagerness to try new things that we didn't originally envisage. So I think that's just, really great to see how positively everyone's contributing and constructively.
In most cases in science, you will produce very small pieces of information, but this time we have opportunity to collect different kind of data from different sources.
With also huge uncertainties of how to do this research, that actually keeps me awake at night, but also gets me up in the morning.